So a big welcome back to the Resources Conservation and Recycling webinar program. My name is Mitchell Jones. I'm the Outreach Editor at Resources Conservation and Recycling, and I am also your host for today and also for the immediate future. So just before we kick things off, a short introduction to the program itself. This is our English language webinar program that's run every second Thursday at 10 o'clock a.m. Pacific time. The scope of the webinar program is effectively matching the scope of the journal. So we are selecting two speakers from each issue, so two articles from each issue of the journal for an invited talk on our program. And we have no bias or no preference when it comes to the theme of the presentation. We simply choose the presentations or the articles based on their scientific merit and how much interest we think they will have for our readership. But you can expect to see presentations on the full range, the full scope of the journal. Could be anything from one end to the other. We don't really have any bias when it comes to that. So the main point, though, is accessibility. So we do try to pick presentations. We do ask speakers to present their findings or their research article in a way that is broadly accessible to a wide audience. So, for example, we have potentially researchers that are working in certain research areas who are interested in adjacent research areas. So they may not necessarily be an expert on the topic, but they do work within that sort of resources conservation and recycling scope. And they might be interested in broadening their horizons a little. And we do want everybody to get something out of the presentation. So we're obviously asking that the speakers are presenting using minimal jargon and terminology that's more accessible to people, and that if they're going to delve into their research area, that they also provide some information, some background information and context for their presentation. Now, for this program in Zoom, where we currently are now, registration is necessary. So you can get those registration links in the newsletter that is circulated at the end of each month via email. Or you can also get them on the Resources Conservation and Recycling official social media channels. So, for example, on X, on LinkedIn, on Facebook, you can find the promotional material and the links for registration on those social media sites. You can also find the links on the official journal homepage. So if you go to the Elsevier journal homepage for Resources Conservation and Recycling, you go to the About tab and you visit our webinar calendar, you can find the links that you need to register for the webinars there. And that basically gives you the opportunity to participate in our program in this online environment. It allows you to ask questions and have a more interactive experience. If you would prefer to watch the content on demand, we also make all of our webinars available in an archived form on YouTube. So this webinar right now is being live streamed to YouTube. So you also don't need to register. You could simply go to YouTube and see this live stream right now. You can also see all of our previous webinars on YouTube. The link is youtube.com/@RCR journal. The final point is that we do really want to deliver a webinar program that caters to your preferences, and your feedback is really important for that. So at the end of this program, you will have the opportunity to fill in a survey if you wish. It is a very short survey. It's, I think, 6 questions. It will take no more than a couple of minutes of your time, and we do really appreciate your feedback. It helps us to deliver a program that caters to your preferences and your desires. So I'm now going to share my screen, and we're going to have a little look at the event program for today. So we've had the welcome address. In a moment, I'm going to briefly introduce the journal. Then I'm going to introduce our speaker for today, Michael. We're very lucky to have Michael with us today. We're going to have a couple of notes on the administration aspects of the program for today. Then we're going to have a 20-minute presentation from Michael, 10 minutes of question time, and then some information on the program, actually. for 2023. This is the last webinar for 2023. Of course, we will continue in 2024, but just a few closing remarks on the program for this year. So the journal information, as I'm sure you all know, the journal is Resources Conservation and Recycling. It's a fairly prominent Elsevier journal, which is interested in, I think the scope is quite obvious from the title, resources conservation and recycling. But the key points really are systems-wide strategies, technological, economic, institutional, and policy focus, resource management practices, conservation, recycling, and resource substitution, resource productivity improvement, restructuring of production and consumption profiles, and transformation of industry. So those are our key interests. If you have high quality research in those areas, we would be very interested in seeing it. The webinar etiquette for today, well, as always, please all communication in English. That's simply just so that everybody can understand each other. This is an English language program. We also have a Chinese language program. If you are interested in that, be sure to check that out. We are providing closed captions. So if you, for example, would be interested in watching the webinar without sound, because you're potentially at work or something like that, or perhaps English is not your first language and you might benefit from some subtitles, some captions, you can enable those. They're available to you. If you have any questions, please feel very free to post them in the Q&A during the presentation. I'm sure that Michael would be more than happy to answer them at the end. And if you see a question in the Q&A that you might have asked, be sure to upvote it so that we can get to it a little earlier than the others. We're also more than happy to have you join us on the floor to have a live question or answer with Michael. So all you need to do, if you are interested in speaking with Michael by using your camera and microphone or just your microphone, is to use the raised hand reaction on your toolbar. And we'll be more than happy to have you speak directly to Michael if time allows at the end. We have about 10 minutes allotted to questions. So our introduction of our speaker for today, we have very lucky to have with us today Michael Martin from KTH Royal Institute of Technology. He's going to be speaking with us on the environmental assessment of greenhouse herb production improvement options, a longitudinal review of improvement options. It was a little long to fit there, so we've condensed it slightly. Michael Martin is a senior researcher at IVL Swedish Environmental Research Institute and an adjunct professor in sustainable production and consumption systems at the KTH Royal Institute of Technology in Stockholm, Sweden. His current research focuses primarily on sustainable food systems and industrial symbiosis, where he leads the Sustainable Urban Food Lab at IVL and KTH and works extensively on optimizing the resource efficiency and sustainability of urban and controlled environmental agriculture. He has published a number of scientific articles and chapters on the use of LCA to assess the sustainability of urban and vertical farming systems, and has been a scientific advisor for the Controlled Environment Agriculture Design Standards, the CEA Footprint Project, in addition to working with the Food and Agriculture Organization to study the life cycle impacts of urban agriculture. So thank you so much for being with us today, Michael. I'm going to stop sharing my screen now so that you are able to.
Great. Yes, and here it is. So I renamed the study or the title of the study for this presentation to Longitudinal Environmental Assessment of Greenhouse Herb Production. You can find the real title on the paper. But on behalf of my colleagues that I actually worked with on this paper, so that's Elin, Laura, Christine, and Francesco. So I'll be presenting the results from what we did during the study just roughly over a year ago. So you already had an introduction to me, so I can skip this this slide, and I can get right into maybe the background of why we did this study, which I think is kind of interesting. So I had a seminar where I was talking about the sustainability of vertical farming and greenhouses, and there was a kind of a heated debate on what constitutes a sustainable system and there was a lot of speculation about what the greenhouses did in Sweden. And actually, the two that were working at Svegro, the name of the company, they actually came up to me after the seminar, and they asked me a few questions because they had started this quest, I would say, like for a sustainable system. And they had a lot of questions for me, and then we kind of started a project together that was within a research project that I had going to help producers become more sustainable. And they asked me questions like, what are the implications of what we have done? They said they had done a lot of things in recent years, and they wanted to understand it does it have an impact, or what can it do? They wanted to know, for example, what was important, what of the things they did was like yeah, bigger or smaller than others, what it is that they should do in the future, but also how do they measure up with other actors, because the greenhouses were often used as like a bad example of what you shouldn't do and different things by others, but also again like what they can do better. And they had lots of ideas like what happens if we do this, and they wanted to get some kind of validation of what would be the implications of that. So I did a study with Svegro, and it's a family-owned company at just outside of Stockholm. So it's on a small island just right next to Stockholm. And they have about 50% of the Swedish market share for herbs in Sweden, which is quite a lot. And it's all produced in this 55,000 square meter greenhouse that you see on the picture here. It looks smaller than it actually is if you're there. Uh, and they primarily produce herbs, but they do have some lettuce, and they've started producing microgreens in recent years as well. And during the time that I studied them for this study, they produced roughly 20 million pots of herbs. So the herbs are all sold in pot, like as potted plants that you can use at home. And this is very common, for example, in Scandinavia to do that, while in other places it might be like cuttings that you have packaged. And they have very ambitious plans for their for sustainable production. And they really want to meet these goals, and they have a lot of ideas about what they should do better. So for this, we basically studied the system using life cycle assessment. And for those of you who aren't up to date with what LCA is, so it's a standard procedure to assess the environmental performance of a product or service. And we typically use it for example, to identify hotspots in areas of improvement, and to review the impacts in products and processes along the life cycle. And we typically call these like cradle to gate or cradle to grave, but in food systems, we often refer to it as like farm gate or farm to fork, etc. And that you can see the processes on the right. We define the goal and scope, we do an inventory, and we do an impact assessment, but all through it, it's a very iterative process. So we have interpretation, and we constantly go back and update and basically the assessment, and we modify it, and we improve it all throughout. So for this study, what I did is the cradle to grave assessment for the greenhouse at Svegro, and we included all inputs, so all the material and energy inputs, the greenhouse infrastructure, the processes for harvesting and packaging, all waste handling infrastructure, etc. What we didn't include is the retail. So we didn't include like how it sits at the retail. It's not always refrigerated. Most herbs are not, some are. And we didn't include the use phase because it's hard to understand like what actually happens with the herbs. If people keep them in the refrigerator or just keep them out. Most of the ones they say to keep them out. The other thing we also did is in the paper, we consider for example, the consumer end of life. So what happens with the packaging and the growing media that's included there. And what we did in this study is we started with a baseline, and then we made these like backcasting and future scenarios to understand what actually happened. So again, if you remember, I said they wanted to know what happened when they did these improvement options, and what did it lead to. So we worked from the baseline data that we got for 2019, and then we created a current scenario in 2021. But from the baseline, we also went backwards to see what happened when they included a pellet burner instead of a bio oil burner. And then when they switched to organic fertilizers from conventional, and this system as it is now, basically the 55,000 square meters of greenhouse, that we called the origin before these improvement options were done. So the baseline is based on data that was from 2019, and it's we collected a lot of data, and this was really a nice surprise. Usually when you're working with LCA, you don't get much data, and you're constantly fighting to get data, and you have to do a lot of assumptions. But Sviagro gave us a lot of data. They had collected everything for the whole year, so basically all production inputs and outputs. They had all of these listed, extensive transportation figures. So all consumables, they had like the logistics, the type of biofuels or regular fuels, and like even the logistics that went out to the market. They also had waste and waste handling methods. So what happened with the waste, how much was it, and even monthly electricity and heat use figures. So we had a lot of good data to work with there. And from that, again, like I said, I built the past scenarios. So if we went backwards from 2019, what happened in 2018 is that they switched out the bio oil burner, and they installed a pellet burner, so wood pellets to supply heat to the greenhouse. Also in this case and all the other ones, they only had about 10% of biofuels in the logistics, while in the current and afterwards it was about 60. And before this scenario in 2016, there was another thing that happened that was interesting. They actually became organic certified, and they did this by having an organic fertilizer put in place. So they took some industry residues and they need to nitrify it. So we included this, and again, it builds on the previous one. So there was no pellet burner. And then we went back and we went to the origin one. And this one was basically the same, but it didn't have organic fertilizer. It only had conventional fertilizer. So we had the recipes that they used then for 2014, which they gave us. Again, it had no bio oil burner and about 10% biofuel and logistics. Then we moved to this current scenario. So we based everything on the 2019. But in the current scenario, what we had is that they actually switched the pots and the trays. So the pots are usually sitting in a plastic container with the pots can sit in there, and the pots and the trays were made of black polystyrene. And what they did is they changed this to green recycled polypropylene. And the motivation for this was basically to reduce the amount of plastic and to allow for recycling. Because the recycling systems here in Sweden can't take black plastic to recycle. It needs to be anything other than black. So they changed the color to green so that you can allow for recycling. And the outer sleeves, they also made a bit thinner, so it saved quite a lot of plastic. Then we looked at the future scenarios, and what they wanted to do here was modify the sleeves. So they made them a little bit thinner. They changed from polypropylene they wanted to change from polypropylene to recycled polyethylene. But this also would incur a slight increase in weight of the plastics, just because they would change to polyethylene and need to be a bit thicker. And we also included in this scenario a change in waste handling and recycling of the plastics. Then we did a scenario for future biofuels because they were working on getting these procurements in place so that all of their logistics could be 100% biofuels. So we looked into this and to see what would happen. And then we also looked into the possibility, because right now they use high pressure sodium lighting, and a lot of greenhouses and vertical farms and things, they're using LED lights. So they wanted to see what would happen if we switched to LED lights. And that would basically incur a reduction of electricity. You would need to add some infrastructure for the LEDs, but also it would require a bit of heat. And I have a picture here of what that kind of looks like, because if high pressure sodium puts off a lot of heat, and if we replace it with LEDs, we would need to increase the amount of heat from pellets. And you'll see that in the two lines that are blue dashed. So there's LED light, that's the amount of energy that's used, and then LED heat, that's the amount of heat from pellets. So you see that we would need to increase the heat line there. Finally, we also did a study where we looked at densification, because this is something that they started to work on. So the rows that are actually in between the channels for the hydroponic system, they wanted to basically bring them closer together. So they had to change actually a bit of their infrastructure to be able to put the rows closer. But this would then move the production from roughly 20 to 30 million pots sold per year. So to do this, we would increase water, nutrients, packaging, and transportation. But what we assumed is that the electricity and heat would stay about the same, as the canopy would be the same amount of lights, etc. This is kind of what it looks like now, and like I said, these would kind of squeeze together a little bit, the rows that you see. So what we found in the current scenario is from our LCA, what we found is that the energy consumption was one of the largest impacting processes for the 5 different impact categories that we have here. And you'll see that in blue, and I have these in I put the percentage, for example, there. But also surprisingly, for greenhouse gas emissions and eutrophication, it's also packaging and even transportation that have quite a large impact for the system. So this other scenarios are interesting to look into further. So when we see these in a longitudinal perspective, where we have this like 2014 to current, and then future scenarios, we can see that these different options that they have, the improvement options that they had in the past, actually had quite a nice impact on the system. So the kilograms per kilo of edible herbs actually decreased quite significantly from 2014 to 2021, and it can decrease even more. The largest being if they do densification in the future. In another graph that we did, we added, I just wanted to add it on the right here, we did a combined scenario as well, which we don't have in the paper actually, but we combined all the future scenarios just to see like what would that do. And we tried to show the annual savings compared to 2014 in kilo or tons of CO2. You can see it's quite significant for the future scenarios. If we look at the kilograms of carbon dioxide per kilogram edible, with and without, if we didn't include the end of life packaging, so the handling of the plastic waste and the growing media, then we can actually we're missing some of the impacts here. So we wanted to show how this impacted the system. So we have with and without end of life. As I mentioned in the beginning, we included this as an important aspect. One reason why we didn't include it in the main assessment is that we don't know actually what happens with the packaging from the consumers. They suggest that you should recycle it, but we don't know if people just throw it away or if they actually recycle it. So we don't really know the actual impacts here. So we wanted to show a sensitivity. And one thing that's interesting, especially in northern climates, so we're in Sweden, Stockholm. I mean, it's like minus 10 degrees Celsius right now here, and we have no sun. It's dark at 3 p.m. Is that there's a large variance in energy demand over the year. So we need this, for example, is the impacts that you see throughout the year from different processes. And as you see, the energy, this is both heating and electricity, that varies quite significantly. So in January and December, the energy demand is quite large, and it actually changes the impact of the product, just because the energy has a large impact on the overall results. So in the dotted green line, you can see the carbon footprint, and the secondary y-axis on the right shows the kilogram carbon per kilogram edible throughout the year. So in the summer, it's quite low, it's around 3, but in the winter it can be up to 6. So it can be almost twice as impactful per pot that you have. And speaking of the energy, it's also very sensitive. So a lot of the companies, and I try to discuss this in the article, a lot of the companies, they buy, for example, certificates for like wind and hydroelectricity, and they want you to include that in the assessment. But I like to be a bit conservative, and I like to do the studies with the Swedish mix. So the average Swedish mix and this is the one that we used on the top. And you can see if we then used other types of electricity sourcing, the results would be totally different. So if we just use wind or hydro, or even the Nordic, so like the regional, like the Nordic region electricity, or then if we chose this certificate with wind and hydro, the impacts would be a lot less from the system. And I would say that I really enjoyed working with Svegro in this project. I don't do that much consulting or anything like this, but we often get a lot of companies that come to us and they want us to do an LCA and get a number. They just want a carbon dioxide number or something like that. And I think that working with Svegro was like the way that it should be when you do an LCA. So it was a company, and they were interested in, for example, finding their hotspots and reviewing what is the implications of things that they did, and see like how can we actually improve the system. So they wanted to get a better understanding, because they didn't understand how to do these environmental calculations. And it's really quite interesting because since we did this study, so the data is based on 2019, 2020 data, they've actually implemented quite a lot of these solutions. So the densification scenario is now in place. They've done this throughout the whole system. All transportation is almost all biofuels, at least for the domestic transport. Since 2022, I think the end of last year, there's a large-scale plastic recycling system in Sweden now. So it can take all of the plastics that you throw away in the plastic bin, and they can recycle most of it. So that could have implications on the study. They also reduced their energy consumption by 17% from 2023 compared to 2021. They've been doing lots of testing on LED lighting, which is really interesting, but they don't have that much to share. They reduced waste, and they've taken steps. One thing I mentioned is that they should try to reduce the transportation distances for their consumables, because they source, for example, peat from Eastern Europe. And then there's peat available in Scandinavia, and we said you should maybe look for domestic sourcing. And they've actually taken measures to do so. So with those, it's my thought is like, is it time for a follow-up study? Since that we've seen these implications of the future scenarios, and we can show this longitudinal effect. One thing that is interesting as well is that we sell these as potted plants. Often, again, it's done in the Scandinavian countries, but packaged herbs, it's also quite common in Europe and maybe the rest of the world. So it's context dependent, and that can actually impact the impact per kilo of sold crops that you have. Again, also the energy sourcing is really important. So even actually when it's used, because you can change the photo period. This is a greenhouse, but you can change when the lights are on and off as well. And the LED scenario is interesting to look at, But one thing that could be interesting to see how this is an older greenhouse, and how how the implementation of LEDs could be a challenge or opportunity, because they have an infrastructure set up for HVS, and they might have a lock-in actually with their heating system. So they have pellets, and it was designed just specifically for the system. And if you install LEDs, you might need to have another pellet burner as well. So overall, I would say my conclusions are that, uh, of course, it was a really nice article to write, and I'm really happy that it's in resource conservation and recycling. But for my own interest, it was really fascinating to follow this study and to be involved. It was because it was really cool to see the improvement measures that were done, and see how much they actually positively influenced the environmental performance of the system. We again showed that the energy system is really important for the greenhouse, as often shown in other studies of controlled environment agriculture. But also it's nice to show these longitudinal studies, so not just a theoretical study, etc., but see actually what happened. And this is a really good case where we have data, and we have a system that's been in place for a while, and we can show what happens. So we can give some empirical evidence to these more theoretical studies of potential improvements. And yeah, just implementations of these measures was really cool, and we really look forward to following up with Svegro to do a bit more. So with that, thank you so much, and you can find my 2 emails for the different organizations I work for here. Thank you.
Thank you so much, Michael, for that presentation. What an interesting topic. I'm always I'm always very interested to hear about the intricacies of modern day farming, and because obviously it's such an important part of our life, right? So I will open the floor if anyone has any questions, but just to give people the opportunity to ask any questions they might have, I jotted down a few things that I thought might potentially cross the minds of your average listener who's enjoyed your presentation. So the first kind of thought that cropped into my mind was we've actually had a couple of people doing stuff with greenhouses speaking on the program, but they were not really talking about herbs. I was just wondering, is there any real difference between when it comes to growing herbs, either in a field or in a greenhouse? Are they better suited or more vulnerable, or in terms of, are they better suited to greenhouse growing because they are more vulnerable to field growing? Is there any particular, not necessarily bias, but is growing herbs in a greenhouse a typical thing? And if so, how does it compare with growing crops in a greenhouse?
Yeah, it's a good question. I would say there's a lot of greenhouses grow herbs, at least in these northern climates, because we have to import most of it. And I would say I also think that maybe a lot of studies look at lettuce because it grows a lot faster, and you can do more trials, and you can have a lot more data. So you might have a bit more like empirical evidence of lettuce. So we see lots of studies about lettuce, but very few, and a lot of studies about tomatoes as well, but very few studies about herbs.
Okay, but so are there any key differences between growing herbs or any other crop in a greenhouse, or it's fairly comparable?
Yeah, it's fairly comparable, but I would say that herbs take a lot longer as well. So the turnaround, it could be months instead of maybe like 30 days. So it takes
Okay.
a bit longer, and it may be a little more vulnerable. And also the impacts can be higher if you look at it, because they weigh a lot less. Uh,
Of course. Actually, this was something that really also cropped into my mind, and I thought might be something that your average listener might be interested in. So you were saying that in these sort of Nordic countries, they're quite often shipping the entire plant in the pot rather than, say, cuttings of the herbs. Now, this I think is a beautiful concept. I think everybody likes to buy their herbs still on the plant. Obviously, the impression is that they are fresher. etc. But the thing that kind of crossed my mind was from an LCA perspective, coming from somebody who doesn't do LCA, is this not maybe an issue? Because obviously a potted plant is going to weigh a lot more than cuttings. So if you're taking into account the LCA associated with transportation per unit mass, or per unit volume of the herbs that you're actually transporting, obviously you're going to have, well, I'm not going to say obviously because I'm not an expert, but I would assume that you're going to have much higher emissions associated with transporting potted plants than you would with a truck full of clippings.
It's correct as well. So that it has some disadvantages, I would say. So of course it's the weight, and you also can't really control what happens with the waste product. So you're giving like this growing media, and there's mixed messages from like the waste handlers. Some say don't throw it in the organic or a compost, and some say do. So you really have to think about that. But also when you have these pots, they also need quite a lot of packaging. So we
Mm-hmm.
see, for example, compared to other systems where you transport like lettuce in bags, the packaging, like the cardboard and the weight, the impact of the transportation is quite high. But it's also really, I mean, I don't know if I mentioned it in the paper now or not, but it's also quite interesting because the plants continue to grow. So we only look at this as like it's delivered to the consumer and you cut the plants. But if you just put it in water or like a nutrient solution, if you have a window or if you have a little LED light, they'll continue to grow and you can get several like runs of the herbs. I do that at home all the time, but that's not included in the LCA. And then I like to purchase them in pots as well for that reason.
I suppose there's also the aspect that the transit time, they are also growing, and also the storage time in the supermarkets. I don't know how long they are storing them before they sell them, but this is all time that you're not using the energy at the facility that you're growing them at. But then, okay, you're potentially using, okay, in the truck, I guess it's maybe ambient or maybe chilled. I don't know how they are transported. But in the supermarkets, I suppose there's obviously energy too. But this is quite an interesting thing. If they are actually storing these in pots for some time and they are growing, then at least some portion of that growth is not attributable to the facility that they were grown at, but
Yeah.
rather in between. That's quite interesting, actually. Do you happen to know what's the weight difference between clippings and a pot? So, like, if you have, I don't know, 30 grams of herbs compared to which would be just the clippings. Do we have any idea how much it weighs, this pot?
Yeah, so the pot weighs around, I believe it's around 200 grams total, but the actual herb part is like around 30 to 40
Okay.
grams of herbs. That's the edible part, not including the roots or anything like that.
Would you consider maybe doing a study at some point where you're looking at the impact of, uh, so you're saying that you could potentially get multiple crop runs, like multiple flushes from the same plant.
Yeah.
It would be really interesting to know whether the amount that you can get out of that just basically compensates for the sort of, what do we got? So like factor six of weight difference between the two. It would be really, that might be something, I don't know. I don't know if that's worth addressing, but I find that quite interesting. Is that something that maybe you'd consider in a future study or?
Yeah, I mean, I really like that. I really like the idea. I think it's hard because we don't know like how consumers use. It would be basically like a consumer study. But
How
also,
long they keep it for, how many flushes they actually bother to take out of it.
yeah, exactly. And because there are greenhouses that do the same thing. So there's other greenhouses in Sweden and other places in Europe where they actually produce herbs very similarly, but they don't sell it at a supermarket, but it's sold to like garden nurseries. And these
Hmm.
ones are very similar, but they go to people's gardens and you get multiple flushes from those in the garden. So you could say that they're similar, and that could be one area to look further into.
Sounds very interesting.
If you
Um,
put the parsley in the garden here, like I mean, I'll get a huge parsley like harvest during the season.
and I suppose okay, it's seasonal, right? You would obviously get nothing in other, but okay, during the right conditions. Very
Unless you have a
interesting.
hydroponic garden in your house, then it works, yeah.
Is that a common thing in Sweden to have a greenhouse or some kind of temperature and environment controlled garden as part of the house? Is that I haven't been to Sweden, so I don't know.
I would say in recent years it has been because we've seen this influx of these like small kind of hydroponic systems, especially during I think during COVID. They
Hmm,
were like selling like
like
very
hotcakes.
abundantly, and yeah, all of the supermarkets had these, and people could you can just take the herbs, you can plant them again and keep them growing. So there's I have one as well. I really like it, so it works well.
Nice. Very nice. I also sort of thought maybe non-LCA people or people who are interested in getting into LCA, they might be interested. You used a few terms in terms of cradle to grate to grave and farm to fork and things like that. Maybe you just want to touch on what you meant by those expressions.
Yeah. So well the typical terms in LCA are cradle to gate, and that would be like a study where we only look at delivering the the product at, for example, the farm gate. So we produce the product and then it's available for purchase, like from the farmer. But then if we extend it and we say that we could have the gate also at the supermarket, so it's available like for consumers, we really have to define like where what we say there. But if we say that we look at cradle to grave, then basically we include everything in the system. So we include it from the production and raw material extraction through to when the product is used and it's discarded and it goes to waste handling.
And farm to fork,
Yeah, that's the same as like a
cradle to grave,
yeah,
except for food, I suppose.
yeah. Food that we talk about like farm to fork, and it goes to the fork, and then you should typically include the grave. You can say like farm to yeah, like to the gate or something as well. So there's different terms, and it's used a bit interchangeably. I like to use the typical LCA terms, cradle to, because most people understand that
Makes
as
sense.
well.
One thing that I really appreciated about your presentation was this note that you said, this slide LCA as it should be. That was really beautiful for me. That sort of hammered home this research impact message that we're trying to sort of promote here. So I just wondered if you maybe wanted to. So you were saying obviously it made a huge difference that the person or the company that you were working with was so open with the data that they had. I was just wondering, do you have any sort of research impact statement that you wanted to make in terms of should this be something that should be not necessarily legally mandated, but it's very hard to do these LCA things without the appropriate data. And you've had experiences, it sounds like, where you've had not so much or not so good data availability and instances where you've had like this one where you've had really good data availability, and it obviously makes an enormous difference if we're actually going to use LCA in the future, which I suppose it seems to be one of our most used tools in terms of fighting climate change, because it really does include everything in a way that many other analyses cannot do. Should we have some kind of mandates in terms of data availability and in terms of trying to get better numbers for things? Because personally, I would quite like to go to the supermarket and see some kind of information on all the products or just on everything that tells you some information about the LCA. Any ideas, sort of visions for a future of in that kind of vein?
Yeah, so it well, at least in our context, so I'm in Europe, and we have they're trying to do that on a European level with the product environmental footprint standards. So they want all products to have a footprint, but it's also quite difficult because you can't do you can't make LCAs for all products without having methods for all products. So you really need methods, and you have to find approaches for data availability, and you have to have lots of concerns about data availability, transparency, and what impact categories are included there. So I'm all for like this product environment footprinting, but I'm also a bit hesitant and scared that it leads to a lot of greenwashing. At the
Mm,
same time, they did this so that you could avoid greenwashing. But if people just start doing the uh, the LCAs just to get a number to benchmark and say my product is better than yours, then they don't. At least in my opinion, LCA has kind of been designed to help companies improve and not just have a number. So I do also appreciate footprints, but at the same time, I'm critical of the use of LCA in that way.
do you maybe have some kind of vision for a way that it could be done well? So, for example, the LCDs were conducted independently. The data availability was mandated. The LCAs were conducted independently by a government organization or a research institution or something like that, or an independent contractor. Or do you have some kind of vision for a better solution?
Mm, yeah, I think that's going to be difficult to implement for all products. Again, like I said, I think it requires quite a lot of work, and we've
Mm,
seen that like the product environment footprint that it's taken a long time, and we still haven't got that far because it requires like industry collaboration, and they have to come to like a common terms on how to do the LCAs to be able to calculate them. And I think one government organization shouldn't do the LCAs. It should be up to the companies to do them, but also be transparent and have them validated as well.
mhm.
So I would like to see that. I think there's good systems like the EPD that are running, and they uh, those are those are things to emulate. And
Excellent.
the PEP will probably get there as well, but it will take some time, and it's really ambitious, but it's really cool at the same time. It's a really interesting case to study further.
It's very nice to hear that you have hope. It's always wonderful to hear experts in their areas that have hope for the future,
Mhm.
rather than, yeah, that's fantastic. Um, maybe we have a few questions now to answer. Maybe a final one. Um, vertical farming. Uh, you so it seems like this company they don't do vertical farming, or they I didn't really, from the pictures it wasn't really clear to me that they
No, it's
did.
just a greenhouse, but
Okay.
they have started a microgreens system, which is
Mhm.
kind of a vertical farm, but in a much smaller scale.
So for people who maybe, I think vertical farming is quite a hot topic. How, generally speaking, how does vertical farming affect an LCA? So if you were going to switch from a greenhouse, normal greenhouse, to vertical farming in the greenhouse, what kind of changes would this result in from an LCA perspective?
Well, the infrastructure is quite different. So instead of like a glass greenhouse, or we would usually have like an industry building, often like repurposed industry buildings. Then we have like several levels of production. So typically they're also hydroponic, but they're not grown in like a soil mixture. It can be any other type of growing media. But then we typically use a lot more energy for those systems because you have to control the heat, or the heat and ventilation, but also the lighting. So there's
Hmm.
no light coming in. You only have artificial light. So you really have to control with the photo period and the LEDs.
Hmm.
Like when it's growing in, you need carbon dioxide, and so it's a bit different. And I've done quite a few studies about vertical farms as well.
And how do they typically compare then to another farming method? Are they generally favorable from an LCA perspective, or it depends? Or
Yeah, it often depends quite a lot, and I would say one of the main things it depends on is not necessarily the technology, but where it's located. So
Mhm.
you need like it has to have a good like temperature range in the location, but also the energy system of that region is the most important thing, because we find that the impacts from the energy system are the largest in all vertical farms, of all the inputs and outputs of the system, just because of the need for the HVAC system and the lighting.
The energy mix always seems to be, from the little that I see of LCA, it always seems to be a huge part of it. Okay, so we have a few questions here. So the first question from the audience: what is the life of the greenhouse structure? Is the effect of capital goods, permanent infrastructures, significant on the environmental impacts?
Yes, definitely. So I would say what we included in this study, I believe it was 25 years for the lifetime, but I think that it can be quite a lot larger. I mean, if you have a system where you don't design it well and you have these large greenhouses and it only lasts a few years, then of course you divide the impact of that system by the amount of years it's running or available. So you really want to design it to have a large lifetime, or to
Mhm.
be able to be repurposed or repaired, especially for greenhouses, because we've seen studies where they actually have large impacts for the infrastructure. And in here it was like, I think also about 10% of the impacts of the system.
The second comment slash question. Thank you for your presentation. You will continue also with an LCC study? Question mark.
No, yeah, we have some data for the costs, but at the same time, I would say that typically LCCs are a bit harder to do because of the not that the companies are always so secret, but they don't want to share all their economic information. So while they share all their inputs and outputs and different things, there's some things that can be secret. Often companies are a bit more secretive about their economic performance and how much they purchase things for, and that would lead to a lot of things being blacked out in the the input output tables. I would like to do it though. I think it's interesting. And then again, we could compare it with vertical farms or field systems, etc.
And the third question here, Michael, thanks for the presentation. I was curious about the composition of the pots for 2021 scenario and the local slash country recycling market. Is the green recycled polypropylene and recycled polyethylene sourced in Sweden? Will be will the effect of recycled material from abroad be significant? Will the effect of recycled material from abroad be significant in the impact categories?
Yeah, I think the first one, let me get back to I don't, maybe I won't share it. But what it's made of is recycled polypropylene. So that's what they're green, the pots, and those are sourced from Sweden. So Sweden has large like plastic molding system. But I would say a lot of the most of the cardboard actually is sourced from abroad. So often companies buy like cardboard boxes from China, and so that has an impact. And we actually have that in the study. I'm not sure if we have that level of detail or transparency in like the supplementary materials, but I have the distances that the all of the pots and the cardboard has traveled as well, and that definitely can have an impact, especially with the cardboard. So we've seen studies where they ship things in a lot of cardboard, like a lot of cardboard packaging. Maybe they have cardboard in a cardboard box and then in a cardboard box, and the cardboard is one area where it can lead to a lot of impacts. But then there was also uh, something about the local recycling market. So right now so a lot of the plastic hasn't been able to be recycled, especially the pots. So a lot of the potted plants were in black pots, and then these optical recycling systems can't recycle the black pots. So they end up going to the incinerator. So what companies have started to do is make them a different color as well. So the green ones can now be recycled. And then we have this big, I think it's called Site One, and it's in a town called Motala in Sweden, and there's a large optical recycling system now. So we can do a lot more recycling in Sweden than we have before, especially for plastics. I think maybe that answered some your questions. Otherwise, you can email me as well.
It's a lovely job, Michael. No, I think obviously the important thing here also about the black, we have to remember that black is absorbing wavelengths of different wavelengths of light. So if you're using a near infrared sorting system or something like that, and you have your beam on black, that's the problem. So we have another question here. Great presentation. Could you summarize all the parameters for successful herb production and how many times the recycling is possible?
Oh, I don't know about how many times the recycling is possible. I mean, there will be some degradation, especially since they sit in water and different things. But the parameters for successful production are definitely the temperature and light, as always for herbs, and maybe even like the storage for them as well. That's really important, and that I don't really touch on too much in the study. But they produce a lot of different types of herbs. Mostly, I would say basil and parsley, but basil and parsley have two different like storage conditions. So basil shouldn't be refrigerated, but parsley can be, and the same with dill and others. So it's also important that the logistics take that into account, because you can ruin basically a whole greenhouse full of like dill if you just leave it out or something, and they won't be able to be sold. So you have a lot of food waste from the system.
Wonderful. Well, that's probably all the time we have for questions. But thank you so much, Michael, for such an insightful and interesting presentation. And I very much enjoyed that question session too. Well, I'm just going to then switch back to the presentation here, because we've come to the end, more or less, of the webinar. And this is the final webinar for 2023. So I just wanted to take the opportunity to give a big shout out, a big thank you to all of our speakers who have spoken in 2023. Of course, a special thank you to Michael for being with us today. And a big thank you also to everyone who has participated in the program in terms of viewing it, in terms of asking their questions, being a part of the program and interacting with our speakers, and also all the people that have, especially the people that have provided feedback on the program in their surveys. We really do appreciate it. And we've been really, really grateful and surprised at the number of people that have provided responses on the program. So thank you to everybody for the program in 2023. I want to wish everybody a Merry Christmas who celebrates Christmas, and Happy New Year. And if you don't celebrate Christmas, then a happy holidays to you. The program will continue in 2024. So stay tuned for that. And that's all from me. Again, thank you very much, Michael, for your time today. It's greatly appreciated. And thank you everyone for coming. I'll see you in 2024.
Thank you. Bye-bye.